You open the book, Life as No One Knows It, The Physics of Life's Emergence, with a distinction between the materialists and the vitalists. So what's the difference? Can you maybe define the two?
I think the question there is about whether life can be described in terms of matter and, physical things, or whether there is some other feature that's not physical that actually animates living things. So for a long time, people maybe have called that a soul. It's been really hard to pin down what that is. So I think the vitalist idea is really that it's kind of a dualistic interpretation, that there's sort of the material properties, but there's something else that animates life that is there when you're alive and it's not there when you're dead. And materialists kind of don't think that there's anything really special about the matter of life and the material substrates that life is made out of. So they disagree on some really fundamental points.
Is there a gray area between the two? Like maybe all there is matter, but there's so much we don't know that it might as well be magic. That that like whatever that magic that the vitalists see. Meaning
Yeah.
like there's just so much mystery that it's really unfair to say that it's boring and understood and as simple as quote unquote physics.
Yeah, I think the entire universe is just a giant mystery. I guess that's what motivates me as a scientist. And so oftentimes when I look at open problems like the nature of life or consciousness or, what is intelligence or are there souls or whatever question that we have that we feel like we aren't even on the tip of answering yet, I think, we have a lot more work to do to really understand the answers to these questions. So it's not magic, it's just the unknown. And I think a lot of the history of humans coming to understand the world around us has been taking ideas that we once thought were magic or supernatural and really understanding them in a much deeper way, that we learn what those things are. And they still have an air of mystery even when we understand them. There's no sort of bottom to our understanding.
So do you think the vitalists have a point that they're more eager and able to notice the magic of life?
I think that no tradition, vitalists included, is ever fully wrong about the nature of the things that they're describing. So, a lot of times when I look at different ways that people have described things across human history, across different cultures, there's always a seed of truth in them. And I think it's really important to try to look for those because if there are narratives that humans have been telling ourselves for thousands of years, for thousands of generations, there must be some truth to them. We've been learning about reality for a really long time. And we recognize the patterns that reality presents us. We don't always understand what those patterns are. And so I think it's really important to pay attention to that. So I don't think the vitalists were actually wrong. And a lot of what I talk about in the book, but also I think about a lot just professionally, is the nature of our definitions of what's material and how science has come to invent the concept of matter. And that some of those things actually really are inventions that happened in a particular time in a particular technology that could learn about certain patterns and help us understand them, and that there are some patterns we still don't understand. And if we knew how to measure those things or we knew how to describe them in a more rigorous way, we would realize that the material world, matter, has more properties than we thought that it did. And one of those might be associated with the thing that we call life. Life could be a material property and still have a lot of the features that the vitalists thought were mysterious.
So we may still expand our understanding what is incorporated in the category of matter that will eventually incorporate such magical things that the vitalists have noticed,
Yeah.
like life.
Yeah. So I think about, I always like to use examples from physics. So I'll probably do that to like, like it's my go-to place. But in the history of gravitational physics, for example, in the history of motion, like when Aristotle came up with his theories of motion, he did it by the material properties he thought things had. So there was a concept of things falling to earth because they were solid-like, and things raising to the heavens because they were air-like, and things moving around the planet because they were celestial-like. But then we came to realize that thousands of years later, and after the invention of many technologies that allowed us to actually measure time in a mechanistic way and track planetary motion, and we could, roll balls down inclined planes and track that progress, we realized that if we just talked about mass and acceleration, we could unify all motion in the universe in a really simple description. So we didn't really have to worry about the fact that my cup is heavy and the air is light. Like the same laws describe them. If we have the right material properties to talk about what those laws are actually interacting with. And so I think the issue with life is we don't know how to think about information in a material way. And so we haven't been able to build a unified description of what life is or the kind of things that evolution builds, because we haven't really invented the right material concept yet.
So, when talking about motion, the laws of physics appear to be the same everywhere out in the universe. You think the same is true for other kinds of matter that we might eventually include life in?
I think life obeys universal principles. I think there is some deep underlying explanatory framework that will tell us about the nature of life in the universe and will allow us to identify life that we can't yet recognize, because it's too different.
You're right about the paradox of defining life. Why does it seem to be so easy and so complicated at the same time?
All the sort of classic definitions people want to use just don't work. They don't work in all cases. So, Carl Sagan had this wonderful essay on definitions of life where I think he talks about aliens coming from another planet. If they saw Earth, they might think that cars were the dominant life form because there's so many of them on our planet. And like humans are inside them. And you might want to exclude machines, but any definition, like classic biology textbook definitions would also include them. And so, he wanted to draw a boundary between these kind of things by trying to uh, exclude them, but they were naturally included by the definitions people want to give. And in fact, what he ended up pointing out is that all of the definitions of life that we have, whether it's life as a self reproducing system, or life eats to survive, or life requires compartments, whatever it is, there's always a counter example that challenges that definition. This is why viruses are so hard or why fire is so hard. And so we've had a really hard time trying to pin down from a definitional perspective exactly what life is.
Yeah, you actually bring up the zombie ant fungus. I enjoyed looking at this thing as an example of one of the challenges. You mentioned viruses, but this is a parasite. Look at that.
Did you see this in the jungle?
Infects ants. Actually, one of the interesting things about the jungle, everything is ephemeral. Like everything eats everything really quickly. So if an organism dies, that organism disappears. Is it?
Yeah.
It's a machine that doesn't have. I wanted to say it doesn't have a memory or a history, which is
Right.
interesting given your work on history in defining a living being. The jungle forgets very quickly. It wants to erase the fact that you existed very quickly.
Yeah, but it can't erase it. It's just restructuring it. And I think
Yeah.
the other thing that is really, vivid to me about this example that you're giving is how much death is necessary for life. So I worry a bit about notions of immortality and whether immortality is a good thing or not. So I have sort of a broad conception that life is the only thing the universe generates that actually has even the potential to be immortal. But that's as like this sort of process that you're describing where life is about memory and historical contingency and construction of new possibilities. But when you look at any instance of life, especially one as dynamic as what you're describing, it's a constant birth and death process. But that birth and death process is like the way that the universe can explore what possibilities can exist. And not everything, not every possible human or every possible ant or every possible zombie ant or every possible tree will ever live. So it's an incredibly dynamic and creative place because of all that death.
So this is a parasite that needs the ant. So is this a living thing or is this not a living thing? So this is
Yeah.
it just
So
pierces the ant. I mean, it
right.
and I've seen a lot of this, by the way. Organisms working together in the jungle, like ants protecting a delicious piece of fruit. So they need the fruit, but like if you touch that fruit, they're going to Like the forces emerge. They're
Yeah.
fighting you. They're defending that fruit
Right.
to the death. It's just nature seems to find mutual benefits, right?
Yeah, it does. I think the thing that's perplexing for me about these kind of examples is, effectively the ant's dead, but it's staying alive now because it's piloted by this fungus.
Mm-hmm.
And so that gets back to this, thing that we were talking about a few minutes ago about how the boundary of life is really hard to define. So, you know, anytime that you want to draw a boundary around something and you say, this feature is the thing that makes this alive, or this thing is alive on its own, there's not ever really a clear boundary. And these kind of examples are really good at showing that because it's like the thing that you would have thought is the living organism is now dead, except that it has another living organism that's piloting it. So the two of them together are alive in some sense, but they're, now in this kind of weird symbiotic relationship that's taking this ant to its death.
So what do you do with that in terms of when you try to define life?
I think we have to get rid of the notion of an individual as being relevant. And this is really difficult because, a lot of the ways that we think about life, like the fundamental unit of life is the cell, individuals are alive. But we don't think about how gray that distinction is. So, for example, you might consider, self reproduction to be the most defining feature of life. A lot of people do actually like, one of these standard different definitions that a lot of people may feel like to use in astrobiology is life as a self sustaining chemical system capable of Darwinian evolution, which I was once quoted as agreeing with. And I was really offended because I hate that definition. I think it's terrible. And I think it's terrible that people use it. I think like every word in that definition is actually wrong as a descriptor of life.
Life is a self-sustaining chemical system capable of Darwinian evolution. Why is that? That seems like a pretty good
Yeah, I
definition.
know. If you want to make me angry, you can pretend I said that
Mhm.
and believed it.
So self-sustaining chemical system, Darwinian evolution. What is self-sustaining?
Well,
What's so frustrating? I mean, which aspect is frustrating to you? But it's also
all
those are
of them.
very interesting words.
Yeah, they're all interesting words. And together they sound really smart and they sound like they box in what life is, but you can use any of the words individually and you can come up with counterexamples that don't fulfill that property. The self-sustaining one is really interesting thinking about humans, right? Like we're not self-sustaining, we're dependent on societies. And so, I find it paradoxical that it might be that societies, because they're self sustaining units, are now more alive than individuals are. And that could be the case, but I still think we have some property associated with life. I mean, that's the thing that we're trying to describe. So that one's quite hard. And in general, no organism is really self sustaining. They always require an environment. So being self sustaining is coupled in some sense to the world around you. We don't live in a vacuum. Um, so that part's already challenging. And then you can go to chemical system. I don't think that's good either. I think there's a confusion because life emerges in chemistry, that life is chemical. I don't think life is chemical. I think life emerges in chemistry because chemistry is the first thing the universe builds where it cannot exhaust all the possibilities because the combinatorial space of chemistry is too large.
Well, but is it possible to have a life that is not a chemical system?
Yes.
There's a guy I know named Lee Cronin has been on a podcast a couple times who just got really
I know
pissed
that
off
guy too.
listening
What a
to this.
coincidence.
He probably just got really pissed off hearing that. For people who somehow don't know, he's a chemist.
Yeah, but he would agree with that statement.
Would he? I
I
don't
think
think he
so.
would. I don't think he would. He would broaden the definition of chemistry until it would include everything.
Oh, sure.
Okay, so
Or
you're,
maybe, I don't know.
but wait, but you said that universe, that's the first thing it creates is chemistry.
Where very precisely, it's not the first thing it creates. Obviously, like it has to make atoms first, but it's the first thing. Like if you think about, the universe originated, atoms were made in, Big Bang nucleosynthesis, and then later in stars, and then planets formed, and planets become engines of chemistry. They start exploring what kind of chemistry is possible. And the combinatorial space of chemistry is so large that even on every planet in the entire universe, you will never express every possible molecule. Um, I like this example actually that Lee gave me, which is to think about Taxol. It has a molecular weight of about 853. It's got a lot of atoms, but it's not astronomically large. And if you tried to make one molecule with that molecular formula and every three-dimensional shape you could make with that molecular formula, it would fill 1.5 universes in volume. So with one unique molecule.
Hmm.
That's just one molecule. So chemical space is huge. And I think it's really important to recognize that, because if you want to ask a question of why does life emerge in chemistry? Well, life emerges in chemistry because life is the physics of how the universe selects what gets to exist. And those things get created along historically contingent pathways and memory and all the other stuff that we can talk about. But the universe has to actually make historically contingent choices in chemistry because it can't exhaust all possible molecules.
What kind of things can you create that's outside the combinatorial space of chemistry? That's what I'm
Well,
trying to understand. Is there some?
oh, if it's not chemical. So I think some of the things that have evolved on our biosphere, I would call as much alive as chemistry, as a cell, but they seem much more abstract. So, for example, I think language is alive. I think, or at least life. I think memes are. I think,
You're saying language is life.
yes.
Language is alive. Oh boy, we're gonna have to explore that one. Okay, but
Life maybe not alive, but I don't know where I stand exactly on that. I've been thinking about that a little bit more lately, but mathematics too. And it's interesting because people think that math has this platonic reality that exists outside of our universe. And I think it's a feature of our biosphere, and it's telling us something about the structure of ourselves. And I find that really interesting because when you would sort of internalize all of these things that we notice about the world, and you start asking, well, what do these look like if I was, something outside of myself observing these systems that we're all embedded in, what would that structure look like? And I think we look really different than the way that we talk about what we look like to each other.
what do you think a living organism in math is? Is it one axiomatic system, or is it individual theorems, or is it
I
individual
think it's the
steps of?
fact that it's open-ended in some sense. It's another open-ended combinatorial space, and the recursive properties of it allow creativity to happen, which is what you see with like the revolution in the last century with Gödel's theorem and Turing, and there's clear places where mathematics notices holes in the universe.
So it seems like you're sneaking up on a different kind of definition of life: open-ended, large combinatorial space,
Yeah,
room for creativity,
definitely not chemical. I mean, chemistry is one substrate.
restricted to
Yeah.
chemical. Okay, what about the third thing, which I think will be the hardest because you probably like it the most, is evolution or selection.
Well, specifically, it's Darwinian evolution.
Darwinian.
And I
Okay.
think Darwinian evolution is a problem. But the reason that definition is a problem is not because evolution is in the definition, but because the implication is that, most people would want to make is that an individual is alive. And the evolutionary process, at least the Darwinian evolutionary process, most evolutionary processes, they don't happen um, at the level of individuals, they happen at the level of populations. So again, you would be saying something like what we saw with the self-sustaining definition, which is that populations are alive, but individuals aren't, because populations evolve and individuals don't. And obviously, like, maybe you're alive because, your gut microbiome is evolving, but Lex as an entity right now is not evolving by canonical theories of evolution. In assembly theory, which is attempting to explain life, evolution is a much broader thing. So,
So an individual organism can evolve under assembly theory?
yes, you're constructing yourself all the time. Assembly theory is about construction and how the universe selects for things to exist.
What if you reformulate everything like a population is a living organism? So,
That's fine too.
right.
But this again gets back to so I think what all of the, like, we can nitpick at definitions. I don't think it's like incredibly helpful to do it, but the reason for
But it's
me,
fun.
yeah, it is fun. It is really fun. And actually I do think it's useful in the sense that when you see the ways that they all break down, um you either have to keep forcing in your, like, sort of conception of life you want to have, or you have to say all these definitions are breaking down for a reason. Maybe I should adopt a more expansive definition that encompasses all the things that I think and our life. And so for me, I think life is the process of how information structures matter over time and space. And an example of life is what emerges on a planet and yields an open-ended cascade of generation of structure and increasing complexity. And this is the thing that life is. And any individual is just a particular instance of these lineages that are, structured across time. And so we focus so much on these individuals that are these short temporal moments in this larger causal structure that actually is the life on our planet. And I think that's why these definitions break down, because they're not general enough, they're not universal enough, they're not deep enough, they're not abstract enough to actually capture that regularity.
Because we're focused on that little ephemeral thing that we
Yeah,
call
it's like
human life.
Aristotle focusing on, heavy things falling because they're earth-like, and, things floating because they're air-like. It's the wrong thing to focus on.